In this video, we're doing free response question 2015. It's question number 3, so no calculator, and this one was a shared question both in Calc AB and Calc BC this year. Take a moment and read the question, familiarize yourself with it, and then we'll continue. Thank you for reading the question. Let's go ahead and start with part A. And in part A, Joanna is jogging along a path. We have a velocity function, so keep in mind this is v of t in meters per minute. In part A, use the data in the table to estimate the value of v prime of 16. So that would be a derivative or a slope. So we want to do these 2 points because 16 is between 12 and 20. So 240 minus 200 over 20 minus 12. So that would give us 40 over 8, which would give us 5. And notice we have meters per minute over here, so that would be meters per minute squared here. 5 meters per minute squared, 1 point for the approximation. Kind of cheap, that one. Part B, using correct units, explain the meaning of the definite integral. So notice the absolute value bars. Absolute value bars means total distance. So this would be the total distance Joanna jogged along the path from 0 to 40. Now I want to approximate the value of that using a right-Riemann sum with 4 subintervals. Well, since we have absolute values for v of t, we're going to need to make this 220 positive. A right-Riemann sum means we will not use the first value. We will need to figure out what we're skipping by. So 12, 8, 4, and 16. So our first Riemann rectangle would be 200 times 12 plus 240 times 8 plus 220 times 4 plus 150 times 16. It's no calculator question. We'd have to work this out. And notice we want to make sure to put meters in our answer. So we've got 1 point for the explanation, total distance traveled or jogged in that realm. Right Riemann sum would be any of these or that top piece, and 1 point for the approximation. Part C. Bob is riding his bicycle on the path now from 0 to 10, and his velocity is modeled by a different function, and we want to find Bob's acceleration. Well, to go from velocity to acceleration, we need to take the derivative, so they're asking us to do b prime of 5. So b prime of t would be 3t squared minus 12t. B prime of 5 would then be 3 times 25 minus 12 times 5. So 75 minus 60 would be 15. And notice in our answer we need to make sure to put the correct units, meters per minute, or per minute squared. 1 point for the derivative, 1 point for the answer. Finally, part D, based on the model B from part C, find Bob's average velocity during the interval from 0 to 10. So an average means we're going to do 1 over 10 integral from 0 to 10 of the function that they gave us, b of t dt. Now, the function that they gave us, if we look back, was t cubed minus 6t squared plus 300. So is that? T cubed minus 6t squared, t cubed minus 6t squared, losing my mind here, plus 300 dt. So we would use the power rule. We'd have t to the fourth over 4 minus 2t cubed plus 300t from 0 to 10. We would have to plug in and then divide by 10. I'll let you do those calculations. But we end up with 350 meters per minute. 1 point for the integral, 1 point for the derivative, and 1 point for the answer.